Hi doctors, how are you? Welcome to week number 8 of our free weekly quiz where we are going to discuss about dental materials. Oh no. Dental materials are a very annoying topic. Yes, no one can deny that, but you need to understand this topic before you go to the restorative, pediatric, prosthodontic material, because once you understand this, it will make it easy for you to navigate through the other topics. I don't want you to invest that much time over this topic. I'm trying to give you the most important 5 topics that you need to understand and to grasp the concept for dental material and move. Like, don't invest that much time to understand in depth about this material. And let's start with our first question. During impression taking, a clinician noticed voids on the closer surface of the cast after boring the dental stone. So you did the impression and then the cast itself ended up by a void. So what is the most likely cause for this, or the reason? High viscosity of the gypsum mix preventing flow? Oh, might be, but this will be generalized. It will not be one contact. High contact angle between the impression material and the gypsum? What's the meaning of contact angle? Let's discuss this one next slide. Excessive vibration during boring. Excessive vibration mean less void, mean intimate contact between the impression and the cast, the liquid of the cast before it's set. So I think this will exclude this error. Low ambient humidity during setting. Let's see about this one also. But before we move, let's understand what's the meaning of contact angle. So contact angle is this angle, is the angle forming between the liquid and the surface. So what is the liquid as a surface in our example here? The liquid is the stone itself, and the surface is the alginate impression, or the impression you are going to pour. So here, the contact, as you can see, when the contact angle is a small, acute, as you can see here, the contact area is small, so the surface contact between the liquid and the surface is big. So this is what we call good adhesion, which is going to end up by good wettability. On the other hand, look here, when the angle is obtuse, the angle is big, the angle is more than 90 degrees. So this means the surface area, which is contacting between the liquid and the surface, is less. So this is going to end up by less wettability, which is going to end up by poor adhesion. So this is the factor to determine wettability or no wettability. And this depends on 2 factors, the surface energy of the solid and the surface tension of the liquid. Some liquid are bad, some mercury, like if you put mercury over glass, this is bad. And some surface are also bad, like if you go for wood, if you go for like rubber, it's bad by itself. But if you go to glass, this is good, high surface energy. So let's see what's happening here. Voids on the closer surface commonly caused by poor wettability between the impression material and the gypsum slurry. Slurry here means like the status between the liquid and the solid. So it's jelly, or you can call it gel form. This is the definition of this one. Wettability is determined by the contact angle. High contact angle, as we said, more than 90, poor wetting, air trapment ending up by voids. Low contact angle, good wetting, accurate reproduction of the surface detail. Hydrophobic, phobic mean like fear, so hydro, water. Hydrophobic mean fear of water, so does not like water. Hydrophobic impression material, like some silicons, resists gypsum flow, leading to air bubble trap, and the fine details, especially pits and fissure of the closer surface. So the answer here will be high contact angle, which means poor wettability, ending up by air bubble. Let's see the other option. High viscosity, thick gypsum may reduce flow, but not primary cause of localized occlusal voids. So high viscosity is going to end up by no occlusal anatomy. It will not be only one point. Excessive vibration, this is mechanical to get rid of the voids, get rid of air. So this is, on the other hand, boom, it helps remove bubbles, not create them. So opposite effect. Low humidity, environmental factor which affects setting, not surface void formation. So this might end up by the cast in total is weak. The cast in total has this like porosity, so it's not very solid when you hold it in your hand. This is not directly rated. Here in the question we have 1 point. Cast after pouring with void on the closer surface. So most likely reason is the high contact angle. This is very important for you to understand, because this will make your life easy when you go to understand the etch, the bond, and everything related to adhesion of the composite. Next question. Which of the following impression materials is most hydrophilic? Water-philic love, so hydrophilic love, water. Polyvinyl siloxane, polyether, polysulfide, condensation silicone. So the question mainly asking you about the rubber. Which one of the rubber is most hydrophilic? Love, water. So let's get it in order. The hydrophilicity refers to the ability of impression material to interact with moisture and allow proper flow in the presence of saliva or fluid. And this feature is extremely important for us as dentists because whatever you are going to do inside the oral cavity, you are going to end up by some contamination of saliva or blood. You're going to do a traction cord. Maybe you can do it under isolight to make isolation perfect. But at the end of the day, we love our material to be hydrophilic. Polyether is inherently hydrophilic, allowing excellent wettability and accurate detailed reproduction even in moist environments. Followed by polyvinyl siloxane, which is naturally hydrophobic. So hydro does not love water that much, but can be modified with surfactant to improve wettability. Followed by polysulfide, has moderate wettability but is less hydrophilic than the polyether. Finally, condensation silicone, which is generally hydrophobic. And this is like ironic because most of us using condensation silicone. Some, if you are a fancy clinic, maybe you can use PVS or additional silicone, but most of us are using this one. This makes polyether particularly useful in subgingival impression, an area where moisture control is difficult. Oh, so you're telling me now the polyether is the best, so why we don't use in clinic? Because it's expensive and it's very stiff. So most likely you will use this one for amazing dental implant. You don't want to risk your dental implant and you have less height of contour to go through because you have just abutment. So most likely polyether will be used for implant, but the most commonly used impression material is polyvinyl siloxane. One more question for you. What is the impression which has the best hydrophilicity? Which type of impression has the best hydrophilicity? And you'll be shocked when you know the answer. Moving to the next question. A posterior composite restoration fails prematurely due to marginal leakage. Which factor is the most likely underlying cause? And this is very important when you read the question and when you solve for AFK exam. Do not assume. The question telling you posterior composite fail prematurely, which means like after 6 months, after 9 months, and he's telling you due marginal leakage. So he's telling you the answer. So he's asking you what is the reason. Let's see. High compressive strength of composite. Yeah, it might lead to failure, but not this one. It might lead to amazing. What do you think? Okay, let's see in the comment. Polymerization shrinkage stress exceeding bond strength, maybe. Increase filler particle size. So when you increase the filler particle size, what's going to happen to polymerization shrinkage? Amazing, reduce. So when you increase the filler particle size, do you think the shrinkage, polymerization shrinkage will be more or less? Last option, low modulus of elasticity of the enamel. So this is slightly outside our context. So let's understand what's happening here. Composite resin undergo polymerization shrinkage, usually between 2 to 3% during curing. This shrinkage generates internal stresses at the tooth restoration interface. Because when you put the composite inside the cavity and you put the light cure from here, so the light cure leading to polymerization, so the composite shrink away from the surface, ending up by weak bond in this area. And we have some maneuvers to deal with this one, but let's understand the concept here. If this is stress due to the polymerization due to light coming from only one surface exceed the adhesive bond strength, it will lead to gap formation, micro leakage, secondary caries, and post-operative sensitivity. So if it happened in the periphery of class 2, secondary caries. If it happened very close to the bulb, it's going to end up by post-operative sensitivity, and for sure it's going to start by gap and micro leakage. Posterior restoration are especially susceptible due to high C factor, configuration factor. What is this C factor? And there is a point I would like you to know from this question. So the C factor is bonded surface divided over the unbonded surface. As you can see here for class 4, this is the best C factor configuration because end up by 1/5 because we have 1 bonded surface, 5 unbonded. As you go here to class 2, 4 divided by 2 still in a good way, but when you end up in class 1 or class 5, this is what you are going to end up with. 5 bonded surface and 1 unbonded surface. So the C factor here is 5 compared to the best, which is class 4, to be 1/5. So this is 20%, this is 5 times. So what do you think is worse? Amazing. In class 1 and in class 5. And how we overcome this error we do incremental packing. So you put the composite this way, you put it this way, so you are converting your class 1 into 2 class 4. Why? Because you end up by composite bonding here and here, maybe 2 surface and 3 surface, which is free. So you make it like class 2, or you make it like slightly class 3 or class 4, but you are going to avoid what happened in class 1 and in class 5, because if you're going to put it just one shot here and you cure, you are going to end up by gap, leakage, and recurrent caries and failed restoration. Let's see the other option. High compressive strength, this is mechanical property. This will improve resistance to fracture. So this is the other way. It's not related, and it will lead to better mechanical withstanding of the composite. So it will not lead to failure. Increased filler, which affect polish and strength, does not directly cause marginal gap. And the filler size, when the filler increase in percent or in size, this will decrease the polymerization shrinkage. Low modulus of enamel, so it is biological property. Enamel is rigid, so this option just to tip you off from the question. So the answer here, polymerization shrinkage stress exceeding the bond strength. This is related to configuration factor, which is exclusive to composite. Whereas 1 and 5, we overcome this by incremental packing. Amazing. Next question. Which of the following factor increases the strength of gypsum product? So we have gypsum product. How do we increase it? Increasing water to powder ratio, decreasing spatulation time, increasing water to powder ratio and porosity, decreasing water to powder ratio. Okay, again, this is within limit. It's not like increasing to the watery or decreasing less grainy, but like within limit. So we are aiming here to increase the strength of the gypsum product. Let's see. The strength of gypsum product is primarily influenced by porosity after pouring. So we have this one, liquid powder. We should mix it, and every one of us, we put the powder and then we add the liquid for upon it, which is wrong. You should do it the other way. Bowl with the water and then you add the powder over it. So this way you can mix it. We make sure you have less porosity, and we do it under vibration, and we mix it that way under pressure. So you make sure your mixing is fine. Why I need to know this? I'm really sorry for this. I know you are a dentist, you are not a technician, but like you need just to understand so you can follow the concept here. So if you go with the low water to powder ratio, and again, this is within the limit. This is within the limit. So this will lead to less excess water, which is going to reduce porosity after pouring, which make denser crystalline interlocking, which is going to end up by higher compressive strength. So we have water, powder, so we are mixing them together. We would like to reduce the void, reduce the residual water, make the crystalline to be more locking and more interdensing together, shows reducing the porosity, increasing the physical property. On the other hand, higher water to powder ratio will mean more water, increased porosity, weaker structure. Proper manipulation is critical because gypsum strength depends on the density of the crystalline structure. Decreasing low porosity, strong, dense gypsum. Increase water powder ratio, more water, weak and porous structure. Decreasing spatulation. So spatulation means when you do it, this one. So when you decrease spatulation, what you are going to do, you are not going to remove all the air trapped here. So you're going to end up by pore mixing, which is going to end up by weak crystalline formation, which at the end of the day reduce strength, not increasing. Increasing water powder ratio, this is incorrect because this will lead to void content, significantly weak gypsum product at the end. The gypsum product and how it mixes, how the setting reaction and hygroscopic expansion, the setting expansion, this is very important topic. You need to understand it. I'm sorry for that. It's an annoying topic, but you need to understand it. Go watch some videos over YouTube from your course, from your material, but this topic, you need to understand it. Next and final question for today. During amalgam placement, a restoration shows poor marginal adaptation and increased residual mercury. What is the most probable cause? So we end up by poor adaptation and increased residual mercury. What is the cause? Over titration of amalgam, under condensation during placement, use of a spherical alloy requiring less pressure, low mercury alloy ratio. So condensation here is the one to play. What's the meaning of condensation? So you got the amalgam, you titrate over the titration. I think no one nowadays doing this manual one. Anyway, you have this machine to do it, and then you get the mix and then you put it inside the cavity. Condensation is the way to move the amalgam, put it inside the cavity, and then we'll use condenser to do it. You hear this zzz, crack, like zzz voice when you condense it. This is a critical step in amalgam placement. Why? This serves to adapt amalgam to the cavity wall, mean intimate contact between amalgam and cavity, because we don't have chemical or mechanical bonding. Yes, and this is why we end up by conversion of the wall to end up by undercut. Amazing. Which is going to eliminate voids and remove excess mercury from the mix. And this is very, very important, because mercury in this mix is just to do the titration process, because at the end of the day, we'll love the set to be solid, to be having a good physical property. The more the residual mercury, the less the physical properties. Think about it. You have a solid with some liquid inside it. How do you think about the compressive and tensile? So at the end, in our mind, we love the mercury at the end, after doing restoration, to be less, residual mercury to be less. We hope it will be zero, but this is not reality. So in reality, we'll hope to be less. If condensation is inadequate, residual mercury remain trapped inside restoration, which is going to end up by poor adaptation to the cavity wall occur. Why? Because you didn't do this pushing. So you end up by more mercury, you end up by voids or gaps between the amalgam and restoration and the tooth structure, and it's going to end up by marginal breakdown and poor mechanical property develop. Proper condensation pressure ensure a dense amalgam mass with optimal mercury content and marginal integrity. Let's see the other option, because it has some weird concept. Over titration. So over titration is going to end up by hot, soapy mix. So the mix itself will affect the handling, but then not the main cause here. You need to see it in picture from your notes to see how over titration amalgam looks and how under titration amalgam looks. And you can tell me, can you deal with this, or you need to remove it and make a new one? Spherical alloy. So we have an amalgam, spherical alloy amalgam, and admixed, which is mixed between spherical alloy and the irregular shape. So the spherical alloy will have less surface area, which is requiring less mercury, which is going to end up by less residual mercury, which is going to end up by better physical and mechanical property. And this is very important concept for you to understand. If the question corner you telling you, you know what, we have patient, we give him core now, and we should do crown preparation now. And the question corner you between two amalgam, spherical or admixed. So what do you think? Spherical, less surface area, less mercury required, less residual mercury at the end after the setting done. So this will end up by higher physical property faster. So we are going to pick this one. But at the same time, if you are coordinate for class 2, which one you are going to use? You're going to use admixed. Why? Because a spherical is a spheric. If you push it and you do slightly higher condensation force, you might end up by escaping of this sphere beyond the matrix band, ending up by overhanging restriction. So this does not mean this good, this bad. It's related to the scenario, and for sure high copper is the way now. No one is using the low copper. So spherical alloy need less pressure, still require proper condensation at the end of the day, but this is not the causative for this question. Low mercury ratio, which is going to end up by dry mix, which should lead to poor plasticity, not excessive high mercury at the end. So this will end up by opposite finding, because you start with low mercury, so it's make no sense. Start with low mercury and end up by higher residual mercury at the final mix. So here, restoration show poor margin adaptation, increased residual mercury, so this under condensation during placement. Or you can say under titration, but like this is giving you over titration. So this is why I'm trying my best to explain the concept and ignore the question, ignore the option, because once you understand this titration process and you understand over, under, it makes your life easy to understand. If I'm telling you, oh, you know, when you do the core, do spherical, when you do class 2, do admixed. It makes no sense. But when you understand it, this will make your life easy. And this is my final tip for today. Please, doctor, for such topics like this one, like epidemiology, I see most of us trying to memorize the stuff. When you try to memorize the stuff, it will be good for a few days. Later on, boom. And if the question coming like this one question here, if you don't understand this contact angle, it will make your life difficult. So please try to understand the concept, but again, do not invest so much time. What does it mean, do not invest so much time? So if you are trapped in like epidemiology in the type of study, try to do it once, twice, go your nose, go to your course, ask your instructor, watch video over YouTube, and that's it. If you understand, fine. If you don't understand, move. Same for ortho, same for the dental material. But when you go to ICCMS, when you go to direct pulpy capping versus indirect pulpy capping, no. You are going to be resistant. You're going to do everything. If you are going to go to painkiller, analgesics, antibiotic, no. You need to understand this one in depth. But some topics just are here to understand and move. Don't invest so much time over this one. Thank you for watching till the end, and see you next Sunday. Have a good night.